All right, Ren, this is for you. This is Pod 64, and I want to preface by saying Miss Tracy is sick with a cold or something. Probably a cold because I only have sinus. And I have, a little bit of a sore throat from the postnasal drip, but I love you so much that I'm sending you this pod for this recording. All right, let's start with number 1. So you could feel a little bit special. That's why I said that. Number 1, you got it right. It just the way it was written. I'm gonna mark it right, so don't worry about that one. So that's one more correct. Number 2, these are done like where you sub in for X, whatever is in the other label. Okay. So you put negative 4x, you shouldn't have had an x at all. It should have been negative 40. So I don't know if you mistyped and put an x in accidentally when you meant to put in a 0 or what. But for the benefit of the doubt, I'm going to go ahead and solve it for you. G of x equals x squared minus 3x times x minus 2, right? And g is negative 2. So I'm going to put g is negative 2. We'll put negative 2 in for all the x's here. So we're going to stack it just to make it easier. So we're going to put negative 2 squared minus and negative 3 times negative 2 is a positive 6 right here. And then this is negative 2 minus 2. All right. Negative 2 times positive 6 is going to be negative 12. Negative 2, and actually, before I get started, I should solve this. This is going to be, because it's x, it's in a bucket that's squared. So negative 2 times negative 2 would be 4. So that should be 4. Okay, negative 2 times 4 is going to be negative 8. Negative 2 times 6 is, again, negative 12, negative 8, negative 24, negative 16 equals negative 40. All right, so that's how that all works. So like I said, I don't know if you mistyped it because it's really close. So let me know, or just I'll turn it back on and go back and fix it. All right, number 3, you did not answer, so let's spend time on that. Factor the greatest common factor of this, and it's a long one. So 40 x to the 4, y, m to the 7, z, minus 20x to the 5, y to the 5, m squared, z, plus 20 xy squared m. All right, so to find the greatest common factor, we are looking for the biggest number that we can divide out of each of these 3 numbers. So right now, I see, looking at the whole numbers, there's a 40, a 20, and a 20. So we know we could take 20 out of everything. We can take 20 out of here. So let's take 20. Now, everything has an x, right? So we know we could take out an x. Everything has a y, so a y is going to come out. Everything has an m, so an m is going to come out. But only 2 of these have a z, so we can't take the z out because there's not a z over here. So now let's look at what we actually have left. So 20 comes out of here. We can get 2 times 20 is 40. So we can get 2 of those out, right? We have x to the 4 here, x to the 5, and x to the 1. Well, you always take the smallest, I should say smallest. You should take the biggest exponent that will come out of each one of the numbers. And this is x to the 1 is the biggest exponent that you could take out of all of these. So x stays the same. So we take 1x out of here. So that leaves 3 behind. So x to the 3, right? And now I'm going to do the other numbers the same way. So 20 out of 20, that's a 1. 20 out of 20, that's a 1. So if you want, you can stick a 1 here. but we're going to drop it with our final answer because the 1 is always invisible. So x from x5 is going to be x to the 4. And x from here, x minus x, is x goes away. There's no x left anymore, right? So now let's look at the y. We have y to the 1, which tells me it doesn't matter what these are because we can only take one y out of this one. So y to the 1 stays the same. Okay, so no y here, but we have a y5 here, so that means we're going to have a y to the 4 here, right? It's supposed to be a 4. We have y to the 2 here, so one y taken away from that leaves one y behind. All right, now let's look at m. We have m to the 7 here, so m to the 2 here, and m to the 1 here. M to the 1 means we can only take one m out of all of these. So m1 from m7 just leaves m6. m1 from m2 leaves m. And then m from m, this m goes away. So this one's done. All right, we've taken everything out of it. So we can cross through it, it's done. But we still have z's in these. And there's no z in this one, so we have to leave the z here and we have to leave the z here. So that means this one's done and this one's done. So now let's rewrite this as, what's the word I'm looking for? Succinctly, as shortly as possible. 20 xy m 2 x3 m6 z. That's in alphabetical order. This is not. I should probably have done that in alphabetical order. We're going to drop the m1, make it invisible. x4 y4 mz plus y. And that's it. That's our answer. So that's how you find that greatest common factor. That's how you factor this out. All right. Okay, let's look at number 4. We're going to look at it just below here. Let me move this paper up. So number 4 says, move this up a little bit. 6 employees at Larry's T-shirt Palace receive $1,000 bonuses for their superb work. That's awesome. Another 3 receive $700 for their great artistry. What was the overall average bonus that Larry distributed? All right, so he had 6 got 1,000, right? And then 3 got 700. So that equals 6,000. That's how much he paid out to them. And these people got 2,100. That's how much he paid out to them. So he gave out a total of 9 bonuses for a total of $8,100. So when we divide 8,100 by 9, we get $900 is the average bonus that he gave out to people. Do you see how that works? It's the overall average. And that's where you take the total number of people and total amount of money he paid out, regardless of to who, and you average it all out evenly. So he gave out 9 bonuses for an average of $900 a piece. And that would be the number here, $900. All right, let's clear the page. You got number 5 right. Good job. All right, number 6. You did not attempt that one. Let's see what happened. All right, so you have negative, right, over excuse me. I promised you could not catch what I have over the video. All right, so the first thing I do is to look at each problem individually, or each term individually, right? And you're going to look and see what you can combine and simplify first. So we have a negative 3x squared. We know that the numerator is always what's negative. So we're going to rewrite this negative 3x squared y negative 2. And I'm going to bring our denominator up to the top so that we can combine as much as possible. So when we bring something from the bottom to the top, the exponent changes from whatever sign it is to the opposite. So the x negative 2 becomes x positive 2. And the y negative 2 becomes y positive 2. All right, so we see right away that we have negative 3 doesn't change, but we have an x squared and an x squared, and we put them together, that's x to the 4th. Because we add the exponents. So because we add the exponents, we have a y to the negative 2 and a y to the positive 2. Negative 2 and positive 2 is 0, so the y goes away. So that first term just simplifies to negative 3x4. All right, so let's look at the next term. We have minus 2x to the 4. We have y1, y negative 1, right? 1 minus 1 is 0, so the y just goes away. So our next term is going to be minus 2x4. So now let's look at this term. So for this one, we have a 4. We have x3 and x1. 3 plus 1 is x4. We have a y1 and a y negative 1. 1 minus 1 is 0, so that goes away. So we have a plus 4x4. Excuse me. So now here we have minus 2x squared, and then we have a negative x to the negative 2 here. So when we bring it to the top, that changes to a positive, so x squared again, right? So we add those two together, we get minus 2x to the 4th. So these are all like terms because they all have x to the 4th as their only variable. So we can just combine these. So we have negative 3 and negative 2 is negative 5, right? Negative 5 and a positive 4 is a negative 1. A negative 1 and negative 2 is a negative 3. So we have a negative 3x to the 4th. That's our final answer here. But then it says, write the answer with all exponents negative. So to make this negative, we have to put this on the bottom. So negative 3 over x to the negative 4. And that would be the answer that this question is looking for, and that's what we have here. Okay? All right. I hope that clarifies a lot of that for you, sweetheart. Let's look at this graphic problem here. So we have y equals negative 2x minus 5. This is what I put in there. This is the answer key, I do believe. Yeah, that's the answer key. So let me show you how to get there. Let's go down to this graphing part here. Oh, sorry, that's algebra 2. Let me clear that. So here's our little grid, right? And let me draw this over. And I'm going to increase this just a little bit. I'm going to make this a little bit bigger so it's easier to see. All right, there we go. That's a lot better. So now let me switch to green so you can see what we're doing. Our line is y equals negative 2x minus 5. So when we read this, we have to understand that we're reading the format here. This is the point on the y-axis where the line crosses. So we call that our y-intercept point. So for that point, it's always going to be x is 0 and y is this whatever the b is here, the sign that it has and the number. That's always the first point. So in this case, we have a negative 5. So our first point is going to be 0 and negative 5. So 0, x, where the y-axis crosses is on the x-axis, which is the number line, is 0. So 0 and negative 1, negative 2, negative 3, negative 4, negative 5. So that is where the first point is, right? So our next point is going to be based off of the slope. And if we look at the slope, it's a whole number. How do we make a whole number into a fraction? We put it over 1. And slope has to be a fraction, or else we don't know how far to move on the x-axis. And the way we read slope is y over x. And this is how you move. If it is positive, you move up. If it is negative, you move down. X is always to the right, no matter what, because it's always positive, because a denominator can never be negative. It's always positive. So it's always to the right because the positive x-axis is to the right, okay? All right, so we look at our slope, and our slope is -2, 1. So -2 means we're going to go down 2 spaces. That's what that means. It means down 2. Because it's over 1, we're going to go to the right 1 space, because it's always to the right, the x is. So we're going to go 1, 2, 1. That's 1 space. All right. Now, if you look at C, I've picked some points here that are on the line, but they're in the opposite direction. That's okay. You can do that. All you have to do is flip it or pick points on the table. So our equation here is that y is equal to -2x minus 5. Remember your table. Remember how to do it on the table? You pick points for x to find out what y is. So we know that 0, we picked 0. -2 times 0 is going to be -5, because this will be 0, so -5 is all that's left. That's why whatever the b is, you pair it with 0 and whatever the b is for the first point, because whatever 0 is, it cancels out the slope, so you're left here with a -5 no matter what. So when you're stuck at a point where you're on a graph and you can't go any below it, you have to back up and pick numbers that go this way. This is where the table comes in handy. If you're not good at flipping it visually and following the line, then you use your table and it helps you find points the other direction. So what you have to do is you have to go negative. So let's do -1. So we put in -2 times -1 minus 5. That's going to be a +2 minus 5. It's -3. Okay, let's pick -2. -2 times -2 minus 5. That's a +4 minus 5 is a -1. So our next point is going to be -1 on the x-axis and -3. That's what this is. -1, -3. -3 on the y. That's right here. Then our next point is going to be -2, -1. So that's -2, -1, -2, -1. And so there's your line. And you can see it's a straight line all the way through those points. Now, if you can visually go the opposite direction, meaning you can flip this, then that's great. It'll help you go the other way on a graph. All you have to do is flip both of them, though. So instead of going down 2 and to the right 1, you go up 2 and to the left 1. And that's when you need to go backwards. That's when you need to go to the left, you flip it. So if you look from our y-intercept point, we went up 2 to the left 1, up 2 to the left 1. Okay? This is when you move to the right. The natural tendency for the slope, that's what tells you to the right what that is. So if you want to go to the left, you have to do the opposite of the top and the opposite of the bottom if you don't have room on your graph to go to the right. Because you see, we didn't have room down here to go to the right. So we had to go backwards. And you can go backwards by either flipping both signs or using your table to pick some negative numbers. So either way will help you. All right. Most importantly, you needed to label at least the y-intercept and one other point. Okay. All right, number 8. Let me clear this for you, baby. Here we go. All right, this gave you systems of equations you needed to solve for x and y. 3x minus 2y equals 15, and 5x plus y equals 12. Because you have a y by itself, substitution might be the easiest thing to do. So we're going to say minus 5x on both sides. So it says that y is equal to 12 minus 5x. So we're going to take this original equation here, the first one, and then we're going to sub in for what we know y is equal to. So 3x minus 2 times 12 minus 5x, because that's the value of y, and we're putting it in for y right here, equals 15. So now we do some distribution. It'll be 24. That's going to be plus 10x. Add 24 to both sides. That gives us 13x is equal to 39. We divide both sides by 13. X is equal to 3. So in our answer, the x part is 3. And now we have to find the other part. And the way we do that is by putting in our x value here. So y is equal to 12 minus 5 times 3. 12 minus 15. Y is equal to negative 3. So negative 3 would be the other part. Excuse me. So that's how you would find the answer for number 8. Let's clear this. All right, let me get some hot cocoa. My throat's hurting. All right, number 9. When Charles inspected the troops who survived, he found 3,600 were still alive. If 40% died, how many troops did he begin with? So if 40% died, okay, 100% minus 40%, right, equals 60%. So the 3,600 that were alive was the 60%, because that's what he had left. So that we could write a proportion with that by saying that 60%, 60 out of 100, is equal to 3,600 out of some number. You see how that works? This is 60%. This is 60%. So 60%, 60 out of 100, is equal to 3,600 out of some number. So we just do a cross multiplication. 60 times x is equal to 3,600 times 100, 360,000. So we divide by 60. And x is equal to, we drop a 0, 6,000. That's how many he had to start with, was 6,000. All right. And that's the number we have here. All right. I'm just going to clear the page. This says to simplify the square root of 72. Sorry, not 92, 72. So we simplify that. The way we simplify is by factoring. We start off with factoring. So we know that 72 is, and it looks like you just flipped the numbers somehow. I don't know how you did that. 72 is going to be 6 times 12, right? 6 times 12 is 72. This is 2 times 3. And this is 4 times 3. And this is 2 times 2. All right, so we've got everything factored, prime factorization. So we could say the square root of 2 times the square root of 3 times the square root of 2 times the square root of 2 times the square root of 3. That's what that was all about. And now we know that the square root of a number times the square root of the same number equals that number as a coefficient. So this equals 2. This equals times 3, right? All we have left is the square root of 2. So 2 times 3 is 6 times the square root of 2. That's how that works. All right. Moving on. Number 11. Very similar problem to what we did before. Negative 2x minus 5. This is negative 2x plus 5. Let me clear this. And go down here. I'm going to draw our little, somebody's cooking something. I think they're cooking pizza. Woohoo. I don't have to cook lunch. That's awesome. I love it when my husband cooks lunch for me. I don't have to worry about it. It's so nice. He's being a sweetie because I don't feel so good. All right, so again, let's look at our equation of the line, also known as a linear equation. We remember that it's in this format. This is mx plus b, and b is where it crosses the y-axis. So our point's going to be 0 and whatever this b is, right? So that means our first point is going to be 0 and positive 5. So 1, 2, 3, 4, 5. That's our first point. Now, unlike in our last problem, we have room to go to the right. This, again, we have the same slope. It's a whole number, so we put it over 1. Because it's negative 2, that means we're going to go down 2 and to the right 1. Okay? Because x is always to the right, unless you have to go backwards. And then we flip everything. But we're not flipping everything because we have room. So let me show you. I'm going to label this first point, 0, 5. Down 2 over 1. 1, 2, 1. So that's our point. 1, 2, 1. That's our next point. 1, 2, 1. That's our next point. So we could draw a line just like that. And there's our line. That is how we would draw or put in this line or this equation of the line, just like that. Now, if you wanted to, you could take this and you could put it in a table and pick the points. So let's do that. We know that x, we pick whatever we want for x, right? And we put in negative 2x plus 5. That's our equation of the line. And that determines what our y is equal to. So we're going to pick 0 for the first one. Negative 2 times 0 plus 5 is 5. Right? Because 0 plus 5 is 5. And we pick up, let's do 1. And then let's do 2. And because we did 3 points, let's do 3. So negative 2 times 1 plus 5. Negative 2 plus 5 is 3. Look at this. 1, 2, 3. That's on the y-axis. 1 on the x-axis. So 1 and 3 is what we have. And that's what we did just visually looking at the slope. Negative 2 times 2 plus 5. That's negative 4 plus 5. That's going to be a 1. Look. 1 on the y-axis. 1, 2 on the x-axis. 2 and 1. Same point, right? 0, 5. 1, 3. 2, 1. And this one, negative 2 times 3 plus 5 Negative 6 plus 5 is a negative 1. So it's going to be 3 and negative 1. Well, look at this. We have 1, 2, 3, and negative 1, right? 3, negative 1. So whether you do it visually, you can always check it and do it with the table to make sure that your points that you did visually line up. But once you're comfortable with understanding what this is and where to start, you don't have to do the table. You can skip that, except as a mechanism to check your work and make sure you're doing it right visually. All right, and that is how we would get this here. And I just drew some extra points for the heck of it because it's kind of fun after a while once you get the hang of it. All right. Let's do this one on the graph paper as well because it's easier to draw the number line on the graph paper. So I have a number line here. Starts at 0 and it goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? This says to graph x minus 2 is not equal to negative 1. Excuse me. And the domain is reals. Well, if the domain is reals, then that means it's all the numbers because all numbers are real numbers. So what we have to do is figure out what this is. So we say plus 2 on both sides because we need to solve for x. This cancels. X is not less than a positive 1 because positive 2 and negative 1 is 1. So you only have 3 options: less than, greater than, or equal to. So if x is not less than, it's greater than or equal to. So x is greater than or equal to 1. So what we do, if x is greater than or equal to 1 and it's all the numbers, we find 1, we circle it. Because it's equal to, we fill it in, and because it's all the real numbers, it includes what's in between the integers. So what's in between 9 and 10, it includes all of that. So this is how you would graph that. This right here. Okay, so solve it down to where you've solved for x, then look at your signs, and whichever one is crossed out, you can then switch it to the other two, put it together. Sometimes you have 2 that are crossed out. You just cross out, write down your 3 symbols, cross out the one that's crossed out, and then put the other 2 together. Or if you have 2, like if this one were crossed out, then you would use the other one. And then you write it in a way that makes sense. You want to write it for what it is, not for what it is not, right? Write the unnegated, write the positive, value of what it is. And then look at your domain, and that's how you would write it. If it is reals, it's going to be a line. If it is integers of any kind, if Miss Tracy could spell, integers means you're going to put the points on the numbers. If it says positive integers, then you're only going to put it on the positive integers. If it says negative integers, then you're only going to put the points on the negative numbers that are included in whatever this says. So look at your domain. Your domain matters. All right, and that is why it looks like this on the answer key. Number 13, you got correct. Congratulations. You did a good job. Let me clear this. And we have another substitution elimination problem. Let me switch back to blue ink. Y plus 2x equals 12. And you see that this says x plus 2y. I'm going to swap it so that the variables are on top of each other. 2y plus x equals 12. Now, this needs to be the opposite. Or you could do substitution. I think let's just do substitution. Let's subtract 2y from both sides. X equals 12 minus 2y. All right, so that becomes our new equation that we're going to sub with. So I'm going to take this one and I'm going to say y plus 2, and I'm going to put in the value for x because x equals all of this. 12 minus 2y. And I'm going to finish the equation. Now I'm going to distribute y equals 24. Oh, I'm sorry. I already messed up. Y plus 24 minus 4y equals 12. Subtract 24 from both sides. And I get negative 3y is equal to negative 12. Y is equal to 4. So I'd write my answer. That would be the x, and this is the y is 4. So now I'm going to take this, and I'm going to say that this is 12 is equal to, not equal to, 12 minus 2 times 4, which is 8, is equal to 12 minus 8, which is 4. So that's 4 and 4. And that would be how you get those answers here. All right, let's clear the page of this and move on to the next one. All right, the number, number 16, the number of bacteria increased by 280% overnight. Okay, so the number of bacteria increased. So yesterday you had 100%. It increased by 280%. So today you have 380%. Okay? If there were 30,000 bacteria yesterday, how many bacteria were present this morning? So this was yesterday's number. This was today's number. So yesterday's number was 30,000. Right? So if we have 380% today, we had 100% yesterday, right? We don't know how many we have. We just know the percentage. Yesterday, we knew the number. We knew we had 30,000. So now we cross multiply to find what the percentage, 380%, is equal to. So 100x is equal to, and I'll pull up my calculator because that's a big number to do, 380 times 30, 1, 2, 3. All right, that's 11,400,000. All right, we divide that by the 30,000, or by the 100, sorry, because we're going to divide both sides by this. And that gives us that we're going to drop off 2 zeros, basically. 11,400,000. So 114,000 divided by 100. Yeah, 114,000 is how many we have today. All right, so that is how we get 114,000. All right. This right here could be correct. It has, it could be greater than 4. It could also be greater than or equal to negative 3. So I'm going to mark this correct because you did read that right. It's just that there's another option there. So that was not an incorrect reading. It's just not written the way it wanted to be written. So that's fine. It's fine. Because it could be that as well. All right. Let's look at the next one, number 20. Let me clear the page for you. All right, you did good on 19. Number 20. You had 4x plus 4x squared over 4x. The thing to remember when you have an operation here like this and you're trying to simplify, you can't just take away from one of the terms when you divide. You have to be able to apply this to both of the terms. So the easiest way to remember to do that is to rewrite the fraction like this. 4x over 4x plus 4x squared over 4x. So you can split this up between these two terms. Now this makes simplifying it so much easier because now you can see that this is 1. And you can see that you could take 4x away from here and you're left with an x behind, right? You take away the 4, you could take away one of the x's, but you're left with an x up here. So 1 plus x would be the answer, not 4x squared. All right, that's how you have to think about it. Split it up, rewrite it, and then that'll give you a better idea of how to simplify the problem. Okay, then that's probably where you went wrong. You saw the 4x and the 4x, you took that away. But it's a divisor or a denominator that applies to both of these terms. And you have to include the operation. And the best way to do that is to put this under each term and put the operation between. And then you'll get the right answer. Okay, number 21. All right, we are going to evaluate this big long thing. So we have x minus x squared to the 0 times x minus y minus x minus y, the absolute value of. If 2x plus 6 equals negative 4 and 4 minus 3y equals 13. All right, so what you have to do is you have to solve this for x and solve this for y in order to find out what your y and your x equal. So let's do that first. 2x plus 6 equals negative 4. Okay, subtract 6 from both sides. 2x is equal to negative 10. So that means x is equal to negative 5. All right, now we have that. X is equal to negative 5. So we can get rid of this and this. Now let's do the y. Subtract 4 from both sides. Negative 3y is equal to 9. So y is equal to negative 3. All right. So now we have our y value, negative 3. So we can get rid of this now that we know what all that is. Now we can drop our buckets in, right? Now let's look at this right here. X squared to the 0, that's 1, right? That's 1. So we don't have to do anything with this at all. So x as a bucket minus 1, another bucket, minus bucket, bucket. Now we worry about what the buckets were. X is negative 5. So negative 5 goes in here, it goes in here, and it goes in here. Negative 3 goes in here, and it goes in here. Right? All right. So negative, negative, this becomes a positive 3. Negative, negative, this becomes a positive 3. All right, negative 5, positive 3. That's going to be negative 5 minus 1 times a negative 2 minus the absolute value of negative 2. All right, so negative, negative is a positive. So negative 5 plus 2. This is a positive 2, but the negative of a positive is a negative 2. These two cancel each other out. The answer is negative 5. Right there. All right. Let's talk about number 22. 0.62 is a member of what subset of real numbers? So all numbers are real. All number are reals are in the reals set of numbers. Okay? Reals. And all numbers that are a terminating decimal, which this is a terminating non-repeating decimal, it's rational. Okay? Reals and rationals. So you got one of them right, but you didn't get reals. So I'll give you 0.5 for getting rational because that is correct. But you also have to include reals because everything is reals. So by default, you write down reals and then whatever else it's a part of. Okay, sweetheart? So, but good for figuring out the rational part because that was the harder one to figure out. All right, let's look at number 24. I'm going to clear the page. Let me go back up to the top so I have plenty of room. All right, 24. We just have to simplify it. Kp minus 2k, and then we have p to the 0 to the negative 2. Kp times k times p to the negative 2. All right, let's deal with the first one on top. 2 times 0 is 0. All right, so that goes away. That goes away because it becomes 1. So the top, we have k and a k. So we have k squared p to the negative 2. That's the top. All right, now we have negative 2 times 2. So that's going to be to the negative 4, right? And we have k and k. So that's going to be to the 2. And then this is to the 1. So that's going to be to the negative 3. So we have k squared p to the negative 3. Right? Okay, so if I bring all of these to the top, right, to combine as much as possible, I have k squared, and then I bring k2 up here, becomes k negative 2, right? I have p to the negative 2. This will be p to the positive 3 when we bring it up. These two cancel each other out. Negative 2, positive 3, it just leaves p. This is the answer. P. Right here. Alrighty, let's do number 25. We have 3m squared over y to the negative 4. All that squared. And then we have that times m times y, or m over y. So what we really have is 2 times everything in here. So 3 squared m to the 4 over y to the negative 8 times m over y. So that's just 1 and 1 here, right? So that's going to be 3 squared m to the 5 over y to the negative 7. So we bring this up to the top. That equals 3 squared is 9, m to the 5, and then this becomes positive y to the 7, which is what we have here. All right. Very good on number 26. You got that exactly perfectly right. Good job. So let's go clear number 27. Okay, this is one of those funky shapes, and we're going to find the perimeter, right? So we have this rectangle here, and then we have a half circle on top and a half circle on the end. The radius here is 4, and the radius here is 4. This is 6, this is 14. All right, so if this is 4, then the diameter here is 8, so this has to be 8. All right, so we know we have on our flat lengths here, I'm going to use my highlighter, we have 6, we have 8, and we have 14. All right, so we can add 6 plus 8 plus 14, which equals 28, right? So we're starting out with 28 plus. We don't know what the rest of it is. So we have a circle here, or a half circle here, and it's got a radius of 4, and a half circle here with a radius of 4. So if you have the same radius on both of them, right? It's a half circle and a half circle that's the same radius. It's like having one whole circle. So we can just do the circumference for a radius of 4 circle. So that would be, circumference is 2 pi r. We don't have to divide it by 2 because they're identical. So that makes one whole circle. So that's going to equal 2 pi 4 8 pi. So 8 pi. And our dimension is in centimeters. So that's centimeters squared. This is your answer. All right. Now, if you had done this and you had said, okay, this is a half circle and this is a half circle, you could have said 2 pi 4 divided by 2, and you would have gotten 4 pi for this circle. And you would have done the same thing. You gotten 4 pi for this circle, and you just said 4 pi plus 4 pi is equal to 8 pi. Either way you did it, it's still the same. Okay? Same answer. And that's what this is. Now, if you decided to multiply 8 times pi, then you would have gotten 53.12 centimeters squared. Or centimeters, sorry. It's not squared. It's not area, Miss Tracy. Miss Tracy, what are you doing? You're too sick to be doing this. It's centimeters because it's perimeter, right? Sometimes it's helpful to write down what you're doing. Perimeter. Perimeter is not squared. All right. Next question. And you got the last one correct, so we only have one more to do. So we're going to expand by using the distributive property. X negative 2 over y to the 4th. And this is negative x. So what do we do when we have a negative? We always apply it to the numerator. So that goes away there. It's negative x to the negative 2. And we have x squared y4 minus 3x to the negative 2 over y4 minus x squared over y to the negative 4, right? All we do is we take each term one at a time and we multiply it times this. It's supposed to be a y. So negative x negative 2 over y to the 4 times, we turn this into a fraction by putting it over 1. X squared y4 over 1. Bring down the operation. Same thing. We bring in this original fraction. And we bring in the next fraction. Bring down the operation. Final fraction. There we go. Now let's look at each one independently. All right, we have, this is when you have a negative in front of a variable, just put in a negative 1 right there. It's going to make your life so much easier because now you know you have how to deal with that negative. You know you have a number there. So, x squared, x negative 2, x positive 2, those cancel each other out. So we have a negative y to the 4 over a positive y to the 4. Okay? Minus x negative 1 times 3. It's going to be a negative 3. And that's going to be x to the negative 4 over y to the 8 minus, we have a negative 1, x negative 2, x positive 2, those two cancel. So we have a negative 1 over y to the 4, y to the negative 4. Those cancel each other out, so that's going to be a 1 right there. So now let's simplify these. Negative 1 y to the 4, y to the negative 4. These cancel each other out. Minus a negative and a negative makes positive, so it's going to be plus 3 x to the negative 4, y to the negative 8. Negative and negative is going to be a positive 1. All right, so we have a negative 1 and a positive 1. They cancel each other out. So all we have left is 3 x to the negative 4, y to the negative 8. We want all exponents positive, so we're going to put them down in the bottom, and that's going to equal 3 over x to the 4, y to the 8. And that's how we get this answer right here. Okay? All right. And you got this one correct, so congratulations on doing a good job with that. And that is all we have.